All right, first video of our next chapter here. We're going to be discussing some other properties of equality, some properties that we typically don't use in algebra problems, but we will start to use more so in geometry-related proof problems. So in class we talked about, the addition, subtraction, multiplication, division properties of equality, the distributive property, and this step called simplifying where we just add like terms. So here are some other properties of equality. So we have the reflexive, symmetric, and transitive properties. I kind of consider them as a family of properties. And then we have the substitution property, which is something you all should be very familiar with from Algebra 1. So let's focus on reflexive, symmetric, and transitive. Now, the reflexive property of equality is simply just saying that something is equal to itself, okay? It's basically like looking into a mirror and saying, hey, there's me. I'm equal to myself. The reflexive property can be talking about variables like it is here, that a equals a. It could be talking about an angle equaling itself. It could be talking about a segment equaling itself. But anything that is technically equal to exactly itself is the reflexive property of equality. The symmetric property of equality is one we really won't use too terribly much throughout the year, but we discuss it here. So it basically says that if a equals b, so if we have two different things here, then technically the second thing is equal to the first thing, okay? And the transitive property of equality, we will use this quite a bit. So again, I would say reflexive and transitive we definitely use a lot. The transitive property is almost like a domino effect, if you will. It says if a equals b and then b equals c, well, we can kind of connect this together to say, well, then a must be equal to c, which is our conclusion here with the transitive property. So you can kind of think of like one domino, here's the a domino, the b domino, and the c domino. If a is going to knock over b and b knocks over c, well, kind of by default, a indirectly knocked over c through b. Now, one way to remember these three things, a student brought this up to me years ago, and I thought it was a good idea. The reflexive property really involves one equal sign. Okay? The symmetric property technically involves two equal signs. And the transitive property involves three equal signs. So a student asked me if I can just think of 1, 2, and 3, and hey, look, RST, that's already in alphabetical order. So I had a student say RST equals 1, 2, 3. And I thought, hey, that's genius because RST is alphabetical and 1, 2, 3 is numerical in order. So I thought that really worked very well. So that's just something to keep your eye out for. If you see something that has three equal signs in it, chances are there's a high probability that it's going to be the transitive property being used. If it's got one equal sign, it's probably the reflexive, and two, probably symmetric. I'm not saying that's a guaranteed thing, but that's something that hopefully you can easily remember. And then our final property of equality down here, the substitution property. So if a equals b, then b can replace a in any expression. So you would use primarily the substitution property to substitute numbers into variables. So if we went back to say some Algebra 1, if we had f of x equals x plus 2, and we said, all right, well, what's the value of f of 2, which basically that's x, we would take 2, plug it into x, and we'd say, all right, well, 2 plus 2 is 4. We were using the substitution property of equality there. And we will use the substitution property of equality, as you would imagine, quite a bit this year in geometry. Now, besides there being properties of equality, which use equal signs, the equal signs are primarily going to represent specific values, specific numerical values, okay? So we're talking numbers here. But we also have properties of congruence, where we're going to use the congruence sign. And the congruence sign is primarily used when we aren't referring to specific numerical values. So for example, if I had two segments, segment AB and segment CD, and all I'm saying is they're exactly the same. I'm not saying how long they are, but I'm saying that they are of equal value. Then I would use the congruence sign. If I said that AB is equal to 5 and CD is equal to 5, well, that's why I'm using the equal sign here, is because I'm referring to them as numerical values, 5 and 5. Okay? So when no numbers are involved, you're typically going to be using the congruent symbol. When you want to refer to numbers, use the equal sign. So there are three properties of congruence, PCs, and they're just our reflexive, symmetric, and transitive. There's not really addition, subtraction, multiplication, division properties of congruence because we're doing algebra, which is all of equality. So these are the only three congruence properties. And it's, again, the same things that we saw before. So again, look at this. Here's segment AB is congruent to itself. Angle A is congruent to itself. Again, there's only one congruent sign used in each of those. Symmetric properties where we just kind of flip-flop the order of what we're talking about. So if AB is the first thing we talk about and CD is the second, now we're just going to flip-flop and talk about the second thing first, really being congruent to the first thing. And again, we could talk about it in terms of segments or angles. Transitive property. Again, three congruent symbols involved here. Again, more like a domino effect. The domino effect is right here, kind of in between our first two congruent signs. These things need to match, and if they match, then we can take the very first thing and match it up with the very last thing, because that's exactly what we're saying right there. And again, we can do the same thing with angles. So really, we're just going to do one example here that has 6 parts to it. You guys are going to be in charge of the last one that we will discuss tomorrow in class. So we're going to name the property of equality or congruence, a PE or PC, that justifies each statement. All right, so AB equals BA, and if we wanted to, we could put segment pieces up there, but if there's not segment pieces up there, then we're talking about more the measure, the numerical value. So if we say segment AB is equal to segment BA, some of you might be tempted to say, oh, well, look, Mr. G reversed the order. That's a symmetric property. But again, remember, symmetric property, if we just jump back here, it has 2 equal or congruent signs. This only has 1. This is really the reflexive property. And you might say, well, why is it the reflexive property of equality? Why isn't it symmetric? Well, this is saying segment AB and segment BA is really the same thing. It doesn't matter which letter I say first. So instead of saying BA here, I could just say, all right, fine, I'll flip the letters around. It's really AB. So it really is saying the same thing is equal to itself. And since I used an equal sign here, it's a PE and not a PC. All right, the second one here. If 4x plus 8 is equal to 20, then 4x is equal to 12. So we need to see this. This is kind of the beginning, and here's the ending. And we need to figure out what happened between the beginning and the end. Well, if we look over here, I see, well, there was a plus 8, and now it's gone. So how would I get rid of a plus 8? Well, I would subtract it over. And if I subtracted 8 over to the right side, then 20 minus 8, well, hey, yeah, that is 12. So what is this property called of subtracting the same amount on both sides of an equation? That is our subtraction property of equality. So we still have some of the algebra ones, the properties of equality we discussed in class, in the mix. All right, the third one. So again, we need to compare what's going on here and here because we don't have an if-then statement now. Well, this looks kind of like this, except, well, the only difference is the 5 has been distributed. And that's the only thing happening here. So this is the distributive property of equality. The fourth one, if 4a plus b equals 10 and a equals 3, then 4 times 3 plus b equals 10. So we want to look at the if part of this statement, and there's kind of 2 parts going on here. And then we want to figure out what happened between the if part and the then part. Well, here we had 2 pieces of information, and now we only have 1 piece of information. So somehow these 2 pieces of information have combined to be just one thing. Let's see what's really going on here. This, I notice, doesn't have an a in it anymore. So what happened to this a? Oh, well, a equals 3, so it looks like they just substituted 3 into a, and that's all that really happened. Therefore, we have the substitution property of equality at hand. All right, the fifth one. If negative 3y equals 36, then y equals negative 12. So again, what's happening between the if and the then here? Well, let's see. I noticed that this had a negative 3, and now it's gone here. So how would I get rid of this negative 3 that's being multiplied with the y? Well, we would need to divide it over to the other side. So is 36 divided by negative 3 this negative 12 over here? It is. So the process of dividing both sides by negative 3 is nothing more than the division property of equality. But now I throw in a little curveball in here. I also said it could be the multiplication property of equality. Well, how can that be? Well, another way of getting rid of a negative 3 is I could multiply both sides by negative 1/3, because negative 1/3 times negative 3 kind of cancels each other out, and we would be left with y. And if I took 36 times negative 1/3, and if I put that on my calculator, hey, I still get negative 12. So anytime you use the division property of equality, technically you could also use the multiplication property of equality. Anytime you use the multiplication property of equality, technically you could also use the division property of equality. Does it matter which one you use? No, just make sure that you use the right one. Or at least make sure you're using one of these two. All right, the sixth one, I want you guys to try this one all on your own. And this one, there could be a couple different answers depending on how you want to present your case. So we'll talk about this one tomorrow, and that is all for the first video of this chapter.